Hi, pre-calculus kids. It's time to talk about the next section. I'm going to assign this section and then I'm going to move on in class. You'll perform some tasks at home and then I'll go over it in class and then we'll move on to the next section. This works really well with this section. I didn't post over the weekend like I said I would because of what happened, and I was a little upset. I know you guys were too, and I'm not going to talk about that on this video. This section is Extrema and average rate of change. It's a very, very simple idea. We just look at graphs and at first we just see, is it increasing at a certain point? Is it decreasing at a certain point? And they give you sort of points to look at, and they say what's happening to the graph at this point. And is it increasing, decreasing, or constant, remaining constant? It does happen at some points. Don't get tricked into thinking, hey, I'm looking at something that has an asymptote and think of it as increasing, as staying constant. It's actually either increasing or decreasing, but we'll get to that momentarily. Let's look at this graph. If they talk about the graph going from negative infinity, see if I can do this right, there we go, negative infinity to negative 1, all right? This graph is decreasing from negative infinity to negative 1. That's a very simple idea. I think you guys can handle that. But what's happening here from positive 2, right, all the way to infinity, again, I don't know how to draw infinity, it's ever increasing. And if they take certain spots in the middle of the graph, what if they say, what's happening between 0.5 and 1.5, you're going to say it's decreasing. But if they said what's happening between negative 0.5 and positive 0.5, you'd say it's increasing, right? And they just want you to say, what is it going up or is it going down? That's all they want, all right? So that's the easy part. Let's move to the second part of the show. Second part of the show is talking about maximums and minimums, all right? Relative maximums and minimums, or absolute maximums and minimums. Just looking at this graph, right? Right now, this graph only has relative maximums and relative minimums, right? This is a maximum because it's a peak, all right? So a relative maximum or an absolute maximum is a peak. It's where the graph goes up, stops, and turns around, all right? And so this is a relative maximum because it's not the highest point on the graph. Where's the highest point on the graph? Well, it's up there infinitely. So there's no way we could say our absolute max is infinity, and we could say our absolute min is negative infinity, but we don't really care about that. We want to talk about the peaks and valleys. So here's a valley, and this is a minimum. But it's a relative minimum because it doesn't go lower than the graph goes. I mean, it's not as far down as the graph goes infinitely in the negative direction. If we move over to the right a little bit more, we have another relative max. And if we move over a little bit more, we see we have another relative minimum. Right? And that's basically it. Now, what if? I'm going to do a what if. I'm going to take this away, and I'm going to make this graph dive. So what if this graph dove, and both ends of the graph pointed downward, and this didn't exist, right? That doesn't exist. The graph just goes this way, and there are graphs that do just this. This, instead of being a relative maximum, would be its high point. That would be as high as this graph goes, so we would then call it an absolute maximum, and then it would just have a relative minimum and another relative maximum, and then we wouldn't really talk about those extremes using our maximums and minimums. Right? So that's really all there is to it. Sometimes you'll have to look right at the graph, or other times they'll have you put it into a calculator and take a look at it. All right, so that's the next part of the show. The last part, which is probably the most difficult part of this section, and I want to turn to a different page. This is a page out of the textbook. It's going to talk about average rate of change. And average rate of change is simply slope. It's slope at given x values. All right? So you take a point here and a point there on a graph, and you say, okay, what's the slope from this x value to this x value, right? And we're going to find an average rate of change. We're not finding an exact, because that would be the slope of a tangent line, and that's later on down the line. Right now, we're just going to talk about the slope between those given x values, and we're going to use basically that old slope formula, that old slope formula, m equals y2 minus y1 over x2 minus x1, where m is the slope. So y2 minus y1 over x2 minus x1. And remember, we already talked about this, f of x is just another way of writing y. A function of x means what you get out when you put in that x value as a y, okay? And so I'm going to show you, I'm going to walk back over here, and I'm going to show you the formula. The formula states that f of x number 2, y2, what you get out when you input that value, right? Minus f of x1, oh, there it is, y2 minus y1 over x2 minus x1. And I'm going to go ahead and I'm going to write, and probably all over this guy's face eventually, but I'm going to start evaluating this function using 2 and 1. So this is x2 and x1, right? But remember, we input x2 into the function itself and get a y value out, right? So we're going to first input and find a value, find a y value for our second x. So we're going to say 3 cubed minus 2 times 3 squared minus 3 times 3 plus 2. And this is a very easy problem to solve. This is 3 cubed, which is 27. And if you don't know that, it's 3 times 3 is 9 times 3 is 27. We're going to subtract from it. 3 times 3 is 9, or 3 squared is 9 times 2 is 18. Hey, they look a lot alike. Minus 9, hey, look at that. And then plus 2. And what you get out of here is 27 minus 18, which is 9, minus 9 is 0, plus 2 is 2. So we have a 2. Okay, so we'll say that this, I'm going to write up here, this is the y2 minus y1. All right? Now, so our f of 3 is actually 2. Okay, so that's our f of 3 minus f of 2. And I'm going to just write it down here in a space provided. I'm going to say that 2 cubed minus 2 times 2 squared minus 3 times 2 plus 2. Okay, well, this is pretty easy. 2 cubed is 8 minus 2 squared is 4 times 2 is 8. Uh-oh, 8 minus 8. Minus 3 times 2, which is 6, plus 2. All right, so 8 minus 8 is 0, minus 6 is negative 6, plus 2 is negative 4. Okay, well, minus negative 4, right? And then we have x2 minus x1. That's a real easy idea. That's 3 minus 2. So 2 minus negative 4 is 6. 3 minus 2 is 1. Our average rate of change, or our slope between these two x points, is 6. Wow, that's pretty stinking steep for just one point along the graph. So it must be some sort of funky parabola that has, taken off, and this is the in between 1 and 2, right? The in between 1 and 2, you got that little space right there, probably jumps up 6 spaces. Other than that, I'd say that's it. So yes, this is labor intensive. It's not necessarily intuitive right away until I tell you that f of x2 is actually y2 and f of x1, because you're only given x values in this. We're not given x and y values like taking points on a graph. So f of x, we still have to plug it into a function. Now we're using this idea of slope, but we're using this idea of slope and we're turning it into rate of change for functions that were given in pre-calculus. We're not just looking at a graph and taking this point and finding out what the slope is between them. We're trying to find out what's going on with a function between these two x values, and that's pretty important. I think you can handle this. I'm going to post the practice page for you to complete. I'm also going to post the study guide page, but I don't want you to complete it. I'm not even going to post it for you to edit it. I'm not going to post it for you to do the work on it. I'm going to post it for you to view. All right, so if there's anything that you might be able to see on that study guide page to get some more information from, it'll be there. But just the practice page is what I want you to complete. So thank you very much for watching. I'll be back with you 2 days, right? So be good.